I can start explaining, guys.
No.
Okay, all right, just asking. I can start explaining. People, no, not yet. Yes, no. All right, guys, I'm gonna start explaining, right? So, what happens, right? When you drop a rock,
Miss Morris, hold on.
nobody's saying nothing to me. I feel like I'm talking to myself. All right, guys. So I'm gonna start explaining, right? So it says again, right? Sorry. It says what happens, right? When you drop a rock from a cliff. Again, it falls downward, right? So it's pulling down, right? So my daughter knows this. Does anybody know the force that pulls something downwards? It always pulls you down.
Gravity.
Gravity, right? So,
Gravity.
right? So anytime they're describing a downward force in any physics problem, they are inferring, implying, right, that you're using acceleration due to gravity. And I showed you guys on the previous page is 9.81 meters per second square. Again, the questions, they're not going to mention gravity. They're not going to say this is free fall. You're expected based on the description. You have to stop and think, right? So let me just give you guys a little bit of prelude here. Physics, I would say, is 90% thought, 10% action, right? So think carefully before you start figuring out what the question is asking you, right? So think before you start picking a formula, right? And start solving it. If you get a question and you jump into the formula, right? Something is wrong. Stop and think, right? Because they're going to try to trick you. Again, it says when a skydiver jumps from a plane, right? What force? Again, he she will fall to the ground. So anytime you see a question where they're telling you somebody's jumping, right? And they're going downwards, they're describing free fall, which they're basically saying that the only force acting on that person in that moment is acceleration due to gravity, right? Again, when a skydiver speed as he is falling, right? So for this one, we're going to introduce a term what is called terminal velocity, right? So when the skydiver, right, is jump and is falling, right? The terminal velocity is a special term that we're going to use in physics, which we're going to define later on, right? And this has to do with resistance, right? So you guys see how the skydiver dives, right? And then when they open up the parachute, notice how the velocity changes at different times. You guys know what I'm talking about? Right? So sometimes they could slow down, sometimes they could speed up, right? You guys know what I'm talking about, right? So it all has to do with their formation, right? You ever see those skydivers, right? The formation, determines how fast they fall or how slow they fall. That's what we're saying is terminal velocity. Okay? So terminal velocity, I'm going to just do in a separate lesson. All right, guys. So this is free fall. Sorry. What is wrong with this thing? All right. So free fall motion by definition, right? So free fall is basically when the only force acting on the object is gravity. That's the only force acting on the object, right? Every other force is negligible, right? Or means that is not impacting, right, that object at that point. So even though the person is, let's say that somebody's fallen up from a tree, right? I fell out of a tree when I was younger. Don't tell anybody, right? Right. So even though there was some wind, right? Again, the wind is negligible because the net force that's pulling it down is acceleration, right? Acceleration due to gravity. Questions, anybody? All right, guys. So the next one, right? So our goal for today, we're not going to do the experiment, right? But we're going to try to determine the value of G, which is what we I already showed you guys, right? And then we're going to talk about problems that deals with specifically free falling objects only, right? So again, these are some properties of motion that we've discussed before. You guys don't have to write this. We already spoke about that. Displacement, velocity, acceleration. Do you guys remember what displacement is? Is it a vector or scalar?
Vector?
Vector.
Scalar?
Displacement is vector.
Oh.
Displacement is vector. What about velocity? Vector or scalar?
It's a vector.
Yep. What
Vector.
about acceleration?
Vector.
Scalar.
Vector, exactly right. So if you
Vector? Everything is
accelerate, yeah,
vector?
yes. So if you're
Oh, okay.
accelerating, right, if you have velocity, if you have displacement, in physics, you should have a direction. If you have no direction, it means that you're not doing any of these, right? Now, so this is just reiterating again, right? Displacement is the distance and direction that is traveled, right? So the position and the distance traveled. Why does the position matter? Because it matters in what direction I'm going, right? Like we did last week with the ant. You guys remember, right? So it says Alex Rodriguez, it's a home run. What is his total displacement around the bases? So can anybody tell me? You want to write the example and tell me what his total displacement would be if it's a home run and run around all the bases.
Wouldn't it be 0?
Exactly. There you go, 0. Because where he starts is where he ends up, right? And the distance now would be adding up the distance from each of those 4 bases all together, right? So let's say if the distance would be 90 meters each, it would be 90 plus 90 plus 90, 4 times that would be 360. Everybody get that? So displacement and distance again, sometimes they're the same, but sometimes they're not. It all depends on what they're describing. Everybody's good? Yes, Ms. Morris, go away.
Yes, Miss Morris.
Okay. All right, guys. So again, this is just going to velocity. So I'm going to leave this one up here so you guys could copy it, right? So this is just reviewing velocity. Again, formula, right? Substitution with units. Do not leave the units out. And then you solve with units. I'm going to leave it up here for a couple of minutes, maybe like 3 minutes, right? And then we'll go over it. And then we'll get into the free fall. I just want to reiterate while you guys are doing your work, that attendance is automatically taken from Google Classroom. After every live session, it sends me your attendance automatically. It tells me the student that logged in, their name. It tells me the time they logged in, the time they logged off. So for those purposes, you must log in with your New York City DOE student accounts. You cannot log in with any other login, because otherwise, like I said, you're going to be marked absent. All right. So for students that have relatives that go to our school, sometimes I know they'll log in under their relatives, their brother or sister's name, right, or cousin's name. Please don't do that, right? Because I had this last week where parents said their child was there, and I'm like, no, this is the name I saw. And lo and behold, it was a relative's name. So please log in with your own student accounts, okay? I can start explaining yet or no? Everybody's good?
No.
Not yet, okay. So when you guys go to actively learn and you do the question, right? Depending on how you put the answer, right? You're gonna get more points if you show the formula, substitution in units, you're gonna get more points rather than if you just give me the number, right? So if you just put a number, you're gonna get just a basic, just a basic answer, the basic grade, which is gonna be the lowest grade, which would be like 1, right? If you show me the formula, substitution with unit, you get slightly higher grade. So why am I modeling this? I'm modeling this to show you guys what you're expected to do to get a higher grade. Do you guys think physics is easier than chemistry?
Yes.
It is
Kinda.
easier. It is easier. It's pure math. Like I said, if
No,
you guys,
it's just chemistry
uh-huh.
is just too much work. Chemistry is too much work.
It is.
Chemistry is just the elements, and each element have their own.
Chemistry fries my brain.
Chemistry is just that, depends on the element and depends on what we're doing. There's certain rules that won't apply to that element. It's a little bit more specific. That's all. But physics, the formula is universal and that formula always works. It doesn't matter if we're talking about the velocity of a hair running or, a car. It's the same formula. In chemistry, no, it matters. You guys are funny. I can start explaining it or no?
Yes.
Okay, guys. So basically, right again, right? So you're going to write your formula, right? Again. So this time I made sure I changed it. Velocity is a change in displacement, right? Which is delta S, right? Or delta X. All it means is that it's final minus initial, right? Over your time, right? And that arrow that you see over that V right there is basically telling you that is a vector, right? So the question is, right? A home run takes about 3 seconds, 3.5 seconds to clear Shea's center wall, which is 420 feet. What is the velocity of the ball? Again, right? Velocity. So in this question, even though they did not give you the initial velocity, everybody knows that you always start out from 0. Everybody see that? Because some students are going to say, Miss Morris, they didn't give me the initial velocity. How do I know its velocity? Again, everything start out at 0. So if it ends at a number, it's implied, again, implied is inferred that it started at 0. Does that make sense, right? So if it started at a different number, they would have told you that number, right? So if they say that, let's say Usain Bolt, ran, and he started at the 50, meter to 100, they're going to tell you. So if it's not 0, they will tell you the number that they start at. Now, right? Again, you plug in the formula and you substitute 420 minus 0 is 420. 3.5 minus 0 is going to be 3.5, right? So it's 120 feet per second. Questions, anybody? Everybody's good?
Yeah, we're good.
Yeah.
Guys. So now we're going to go into acceleration now, right? I'm going to leave this up there for a couple of minutes while you guys are copying it down. I think we have maybe 2 or 3 more slides and then we're done. So again, for tomorrow's login for the meeting, I'm gonna put it on my classroom also. Ms. Dives is gonna put it in her class. So for the students that do not have AP Research, tomorrow we're meeting at 8:30, right? So just make sure you attend that meeting or log in right to the meeting so you could get credit for the attendance, okay? If you can't log in because you have another class meeting, just email me and let me know.
Wait, what time?
Tomorrow we're gonna be meeting 8:30 because the AP Research class is 8:30. So if you have a meeting tomorrow at 8:30 for that teacher and you can't log in and you do not have AP Research, just email me so I can give you credit for the day.
Wait, hold on. You said for the people that don't have AP Research,
Right.
we gotta go to that meeting.
Yes, because what happened is it's gonna be for my physics class. But remember I told you guys initially that I was supposed to teach one of the AP Research class. So what happened is because he's a mentor, right? And some of I would say 100% of everything that we have to do for the program will actually benefit students tremendously more in the AP Research class. But for our physics class, right? When he works with us, it's gonna be for a project and we do it together and it's gonna be like basically a project grade. Okay. So if you still want to use whatever we did here for your AP Research class, you're open to do that. It's just that you're gonna have to do more details, right? The AP Research paper that you have to write, right, is a lot more complex, right? So if you want to use the same thing for your AP research class, you're free to do it, you know. But for our class of physics, for the purposes of our class, we're going to do it as a project, right? And you'll get credit for the class. It's okay. You can go. You can go. No, no, go ahead. Let yourself. Go ahead. It's okay. All right, guys. Can I start presenting? So here we're going to start off with a question first, right?
No, wait.
No? Okay, okay.
Like 2 minutes.
Okay. I was just asking. You guys know I get excited. And you guys know you made me jealous and tell me that you like physics better than chemistry, so now I'm totally jealous. I can start, guys?
No.
Okay. So remain physics, I told you guys, right? If you can't identify the formula you're using, if you don't have a concept like Newton's first, second, third law of motion, or the law of conservation of momentum or energy, do not proceed. If you cannot identify the formula or a concept, I guarantee you what you're saying is going to be wrong. So the most important thing, stop, think very hard about what the question is asking, right? Go through, write your knowns and unknowns, right? Get your formula. If you can identify the formula, you're on the right track. If you can't identify the formula, in physics, it is wrong. Yeah, there's no guessing game here. You can't just guess it because there's a lot of inference in the questions. I can start explaining it or no?
Yes.
Okay, all right, guys. So again, we're going to start off with the question first, right? So it says a car does 0.8 meters per second in 6.4 seconds. What's the average acceleration for this interval of time, right? Again, how do we know that it's acceleration? Well, this question is specified that we want acceleration, right? So again, acceleration, based on the formula above, change in velocity over change in time. Delta V over delta T is equal to A. And again, you see that little arrow over A tells me that it's a vector, right? So again, I plug in 85 minus 0 gives me 85, right? Again, notice that my units are there. I did not ignore my units. So I know that for algebra, for trig, for geometry, you could ignore the units. In physics, if there is 0 units, you get 0 credits. You must put the units with the number, right? So the rule of thumb is if they give you a unit in the question, and if the student goes and substitute and ignore that unit, the way the grader looks at it, the student is subtracting information. They gave it to you. You are removing that information. They're going to mark it wrong. Everybody's good? So now, right, 6.4 seconds minus 0. Again, remember I told you guys that if they don't give you a starting number, it's always implied that you start at the number 0, right? When I solve, 85 divided by 6.4 gives me 13.28 meters per second squared. Again, so notice that the units for acceleration is meters per second squared. The unit matter. So here, right, if the student put 13.28 meters per second, the grader will mark it wrong because meters per second is not the unit for acceleration. Everybody understand that? It's meters per second squared. Questions, anybody?
Nope.
Wait,
Okay.
why didn't you put it at the last line?
This
For
is
ev-
just, so the last line is explaining what velocity is. Do you notice that?
Yeah, but why
Okay.
didn't you put the square?
Huh?
Why didn't you put the meter times square something.
Okay, so it says the velocity increases by 13.28 meters for every second. Meters, M is on top, second is on bottom. You see it?
No.
Read it again. For every second,
At the
Okay.
top, it says M/S, that's meters per second, and at the bottom, it just says S, that's just second.
oh, you're saying that the M is not there? Yeah, I forgot to put M. I put M there. Okay, I got you. Right? But it's 13.28 meter, right? But if they say for every second, this is a distance that's traveled, it's another way for saying meters per second. Does that make sense? No? If you get paid $5 an hour, they're saying every hour you make $5, yes? So when you write it out in word form, that's what it looks like. When I write it out in unit form, it's just going to say unit over the other unit. Everybody's good? All right, guys, again, right? So just going over vector and scalar, right? Vector has size and direction. Examples like we went over before, displacement, velocity, acceleration, right? Scalar has only size, no direction. Another way we say size, we say magnitude. All that means is a number, like my age, my weight, my phone number, right? How many kids I have. It's just a number, right? An example would be distance, speed, right? Everybody's good? Right? These formulas, again, you do not have to write these down. These are on your reference table. Or do you guys want to write it down? You want to write them down? Hello?
I wrote them down.
I just went to this page. Do you want to write
No,
these down?
I'm going to write it down. I'm going to write it
Okay,
down.
okay, I'm sorry. Okay. So I give you guys like 2 minutes to write it down, and then we get into the free fall question, and then I'm done for today. So when you guys go to do your free falls question, right, on Actively Learn, I don't want any student emailing me telling me that, you know, they can't do it. Well, Ms. Morris, this is hard. It's confusing. Remember, I told you guys again, you have to stop, read the question carefully, look at your reference table, think very hard before you go ahead and proceed. So this is not the class where if class ends at 10:51, you could go to Actively Learn at 10:50 or 10:45 and try to figure it out. Don't get me wrong, there's some people that can't, but I'm telling you that they're not the students that are taking physics in a high school, and it's the first time they're exposed to physics. And if you don't believe me, you could try it. So you need to get here at 10:04, so you could go through Actively Learn, look at the videos, go over your notes, then answer the questions. Because sometimes Actively Learn only has 2 questions. So if you get one wrong, 1 out of 2 is 50%. You know, sometimes it has 3 questions. If I get 1 wrong out of 3, 1/3 is 33%, right? So you can't just rush through the questions and then, oh, Ms. Morris, I made a mistake. So you guys see all these formulas in the reference table, right? These should be at the back where it says, it should say mechanics at the back or kinematics or something, right? And for the students that are taking calc, I'll explain how these formulas relate to your calculus class. Believe it or not, one of the questions on your calculus, I think 2 or 3 questions on the calculus exams is going to be in this form, like for physics, right? So on your reference table, it should be this page right here. It should say mechanic. All of them are there. Can I move it, guys?
Yeah.
Okay. All right, guys. So this is just velocity time graph, right? So just draw the graph and write the you know, the 2 little sentences that I have, because sometimes on the state exam they love to give you visual representations. They want to know if the student could interpret the formula in a graphical expression, so that they, you know, so you know, make sure you write your units right. So they're gonna say velocity time graph. They're gonna say distance time graph, right? They're gonna give you all different type of graphs, and they're gonna ask you what is the slope equal to. The student can't put IDK. By the way, if you put IDK in physics, it's wrong. If the student put I don't understand, the grader is going to mark it wrong. Right? They're looking for, again, a concept, a formula with substitution. They want to see that you try something. So I think after this, we have two more slides, and I think we're done. So next time we meet, we're just gonna do problem set using the different formulas. So the student know when to pick which formula, okay? Because I feel like I'm talking to myself. Am I talking to myself?
No.
Nobody responded to me. I feel like I'm talking to myself. So this is called the velocity time graph again, right? Velocity is on your y-axis. It's in meters per second. Time is on your x-axis, right? So they're giving you a visual representation. So if they say the velocity time graph, right, what does it represent? Again, as time increases in this example, right, because it's an increasing slope, as time increases, the velocity also increases, right? Now, the slope of this graph is acceleration. So if you go back to your reference table, right, what is the definition? What is the formula for acceleration? You guys remember? Delta V over delta T. You guys see that?
Yes,
You guys
it
remember?
was.
So delta V, right? Delta V is in the numerator. T is in the denominator. Whenever you have a numerator divided by denominator, whenever you have numerator divided by denominator, right? And the numerator is on the y-axis. Remember, slope is equal to delta y over delta x. So the reason why this is a slope again is because velocity is on the y-axis and time is on the x-axis, right? So whenever you have delta y over delta x, that is equal to the slope by definition, which you guys learn in algebra and pre-algebra when you guys learn all the way in 6th grade or 5th grade, right? If you're from another country, maybe 3rd grade. Questions, anybody? Right? So the velocity time graph, the slope shows acceleration, right? Now this one, can anybody tell me what this one is? So draw the graph and tell me, can you describe the motion of this graph?
Right, it'll stay constant.
Which one?
Right, it'll be like if you describe it right, you'll say that it's constant, or it's
Which
gonna
one is
remain
constant? What is constant?
the velocity during the time, I guess, or
Okay.
at
So
the time.
all right, so constant mean it's not changing, right? So this one has 0 acceleration. Why does it have 0 acceleration? Because the velocity does not change, right? So on the numerator for the velocity, you're going to have, it's going to be the same number, right? Minus itself. Anytime you have the same number subtracting itself, you're going to get 0. So do you guys see why the acceleration here is 0? Right? So this one, right? Just like the other student, I can't see the student that spoke, right? So the velocity is constant. The acceleration in this case is 0. What I want you guys to understand is that constant in physics does not mean 0 all the time. Sometimes it's constant and 0, sometimes it's not constant, sometimes it's constant and not 0, right? So an example would be, let's say I'm driving home on the LIE, right? If my car is in cruise control and I'm doing 55 miles per hour, my car is in a constant acceleration, right? Constant velocity. My velocity is constant. However, my acceleration is 0. So my velocity at that point would be 55 meters per second, right? Now, what is my acceleration? Because I'm just going 55. It's going to be 55 minus 55. My acceleration will be 0, right? Because 0 divided by any number is going to give me 0. Everybody's good? Yes, no, Miss Morris, go away.
Yes.
Remember, I told you guys, right? You're going to get these questions visually, right? So this is the last thing, right? Just write down that G is 9.8 meters per second square, which I already told you guys. And whenever they have a question relating to terminal velocity, if you see terminal velocity in a question, please don't have a panic attack. Don't be like, oh my God, I don't know what that means. All they're saying is acceleration due to gravity. That's all. The only acceleration force acting on that object is gravity, which is pulling it down, right? So let's say like a mango on a tree falling down, right? The mango falling down, right? Or in Newton's example where, the apple hit him in his head, right? Yes, that's how Newton discovered gravity, believe it or not. The apple hit him in his head.
I heard that before.
Oh, jeez. Yeah. All right, guys. So I think that's it for today. I don't have anything else to say for today.
Go back.
Oh, okay.